Reflection from curved mirrors. A curved mirror is a smooth reflecting part of a symmetrical curved surface such as paraboloidal, ellipsoidal, spherical, or cylindrical. For example, a spherical mirror means a smooth reflecting piece of a spherical surface in any shape, such as circular, elliptic, or rectangular. In case of any curved mirror, if R1 equals to R2 equal to infinity, the mirror becomes plane, that is, radius of curvature of plane mirror is infinite. In the curved mirror, if reflection takes place from the inner surface, the mirror is called concave, and if the reflection takes place from outer surface, act as a reflector convex. So we limit ourselves here to thin spherical mirror swirls. Some point related to the thin spherical mirrors. Pole or vertex is the midpoint of the mirror. Any section of the mirrors passing through the pole is called principal section. Center of curvature. It is the center of the sphere of which the mirror is a part. Radius of curvature. It is the radius of the sphere of which the mirror is part, and it is represented by capital R. And center of curvature is represented by capital C. Principal axis. It is the line joining the center of curvature and the pole of the mirror. Now principal focus. An image point on principal axis for which object is at infinity is that point is called principal focus. Next, focal length. The distance between pole of the mirror and the focus is called focal length. And the aperture. It means the effective diameter of light reflecting area of the mirror. Now we should go to the sign convention for a mirror. In this lecture we will use coordinate sign convention for mirror. These are the some important points related to sign convention. First, whenever and wherever possible, the ray of light is taken to travel from left to right. That is, it means that object is we have to place left of the mirror whenever possible. Second, the distance above principal axis are taken to be positive while below it is negative. Third, along the principal axis, distance are measured from the pole and in the direction of light are taken to be positive while opposite to it negative. This is why in our convention U or V are taken to be negative if in front of the mirror and positive if behind it. That is when we place object in front of the mirror, our object distance will be positive, negative, and if it is placed behind the mirror, the object distance will be positive. Some important point is also to keep in mind. If above convention is valid, then it coincides with right-handed coordinate convention, and if point 1 is not valid convention is still valid but does not remain coordinate convention. There are number of convention and same sign is different conventions have different meanings. So in the result, sign must be properly interpreted. Example, if the focal length comes out to be positive, the mirror is convex, and if negative, concave. Now rules for image formation in mirror, curved mirror. These are based on law of reflection, that is, angle of incidence is equal to angle of reflection. There are some rules. Let's see one by one. First, a ray passing parallel to principal axis after reflection from the mirror passes or appear to pass through its focus. For example, for concave mirror, it will pass through the focus, and for convex mirror, it will appear to pass through the or coming from the focus. Second, a ray passing through or directed towards focus after reflection from the mirror becomes parallel to the principal axis. This is true by the principle of reversibility. Third point, a ray passing through or directed to a center of curvature after reflection from the mirror retraces its path. Uh, it is it is due to reason that here angle of incidence is 0, so angle of reflection also will be 0. So this rule is formed. Now point 4. Incident and reflected rays at the pole of a mirror are symmetrical above the principal axis. As for the as for pole, principal axis acts as normal, and from the laws of reflection, angle of incidence is equal to the angle of reflection. Now we see image formed by a spherical mirror. Earlier we have discussed the rules for making image. Now we will discuss about the image formation in a spherical mirror. First, let's discuss concave mirror. If the object is at infinity, the image will be real, inverted, very small, and at focus. Second, if object is between infinity and center of curvature, the image will be real, inverted, diminished, and between focus and center of curvature. When object is at center of curvature, the image will be real, inverted, equal, and at center of curvature. When object is between focus and center of curvature, image will be real, inverted, enlarged, and between center of curvature and infinity. When object is at focus, the image will be real, inverted, very large, and at infinity. When object is between focus and pole, the image will be virtually erect, enlarged, and behind the mirror. Now the image formation of convex mirror, image formation by convex mirror. In this case, only two types of image will be formed. When object is at infinity, the image will be virtually erect and very small and at focus. And if object is in front of mirror, the image will be virtually erect, diminished, and between pole and focus.